Hi, you're testing, you're streaming. All right, okay. Oluwatobi, so thank you for coming. All right, let's wait for others. Please let me know, how is the orientation? Is it horizontal or vertical? Let me know, please. You can send a comment and let me know how the orientation is. Is it vertical? Sorry, is it horizontal or vertical? Can you see the board? If you can, please let me know. We have 2 more minutes. We're going to start. All right, thank you for exactly 9 p.m. We'll start. We have 15 people online already. How is the orientation? I think it has changed. What's happening? All right. So, and the time is 9 p.m. Hi, this is the Science Chef. You're welcome to our live session on the 2024 WAEC Chemistry on Volumetric Analysis. And today I'll be taking you through the common errors that students normally encounter in the volumetric analysis, which you must try to avoid. So without wasting much time, I will start with this table on the board. Right? Now, please note that whatever you do in the lab is not as important as what you put down. I repeat, whatever you do in the lab on your practical day is not as important as what you put down. Are we together? Fine. So, in that case, it is that it is your records that will speak for you in the presence of your examiners. If you carry out a very beautiful experiment in the laboratory and then recorded poorly, then you are likely going to fail that examination. It's as easy as that. I'm not trying to scare you. I'm really trying to tell you the intricacies involved in marking volumetric analysis practicals. All right, so the first thing that you need to do is to ensure that unit. You're going to carry out a rough titration and 3 other titrations. Right. Now, this is the most important record here your burette readings. And your burette readings, since you're measuring volume with your burette, it must be recorded in what? CMQ. The unit, you have to attach the unit. Then if you columns, that's not really, even if you are attaching it here, nobody will penalize you, but you must. I think it covers the final burette readings and the initial burette readings. Are we together? I think my screen is orientated clockwise. Please let me pause this and is this better now? I think it should be better. Right? Okay. So fine. So look at the table of values here. This burette reading covers the final readings and the initial readings, right? So you don't need to add any unit here. The unit here covers for the final readings and the initial readings. But the volume of A used or whatsoever is in the burette must have its own separate unit. This unit does not cover this unit. Are we together? Fine. That's the first thing. So after ensuring that your appropriate what unit, remember, if you like, you can add CMQ here, CMQ here, CMQ for each of these titration, but it's not compulsory for that here, provided you do that here. After that, the next thing is your decimal places. Your recordings must be in 2 decimal places. Recordings must be in 2 decimal places. If you want to record 18.7, if the volume, the reading that you read off from the burette is 18.7, yes, it will be 18.7, but you cannot record 18.7. It must be what? 18.70, which is what you have. The initial reading is 0.00, and your final reading 18.70. You don't do this. If you do this, you will lose the marks, or they will deduct your marks for what? Inconsistent burette what? Reading. IB burette readings. Are you together? So then, it means that your burette, which is why your readings or your records, your values must be in 2 decimal places. After recording in 2 decimal places, right? Of course, this also must be what? Everything will be in 2 decimal places. Then your burette readings must be consistent in that you cannot have 18.70, 18.53, and 18.67. You cannot get these values from the burette to use. It's not possible, because the lowest calibration in your burette is what? 0.1 CMQ. That's the lowest calibration in your burette. So it's not possible to get 18.53 and 18.67. Rather, this should be what? 18.50 or 18.60, as the case may be. And this will be 18.70. Sorry. This should be 18.70 or as the case may be. So you take the closest tenth of your burette reading. Are we together? You lose the marks, or they'll penalize you for inconsistent burette readings. If you don't record in 2 decimal places, they'll penalize you for inconsistent decimal places. Are we together? After that, you must have what we call concordant values. You must have at least two concordant values. That is, those two values whose difference is not greater or less than 0.1. The difference between them is plus or minus 0.1. Right? So if this is your rough titer, then it's expected that when you're carrying out the first titration, you carry it out in drops. You have to be very careful when carrying out your first titration. You add it in drops until you get the first desired change, and then you stop. Right? So let's assume that for this, that value would be, let's say, our initial started at 1.00. So let's make this 19 points. Let's say 20. 19.20. So that's 19.20. This will give us what? 19. Sorry, our difference here will be what? The volume of A will be 18.20. Right? 18.2. That's a titer value for the first titration, which is wider, or yes, from the now that you've gotten this, these other two values must not be more than 0.1 from this, either above. So if I am to carry out this titration, myself, after getting this value, I will not carry out these other two titrations again. I'll just extrapolate my values and I'll move on. How? If this is 18.2, I will make this 18.10. I'll make this 18.20. 18.20, 18.10, 18.20. This would be the values that I will use, because I was very careful here. And this, my value, is less than my titer value, which means that this is at least has a high level of what? Accuracy. Are you together? So now, with this now, from here I can get my what? Titration. So this will be what? 18.10 plus 0.00 will be what? 18.10. And this 18.20 plus this will give me what? 21.20. So that if I subtract 3 from 21.20, I get 18.20. This will give 18.10 minus 0.00, I have 18.10. Are we together? So my average titer here, will be what? I will not use my rough in my titration. In calculating my average titer. My rough is not to be used in calculating my average titer. And any value that is out of this range will not be used for calculating my average titer. What do I mean? Let's assume that this was, let's say 21.5. 18.5. So I have 18.5 here. Yes, it's less than this. If I want to calculate my titer value, I cannot add this 18.5. I'd rather use just 18.2 and 18.1 for calculating my average titer. Is that understood? Why? Because this is not a concordant value. Are we together? Please take note of that. So, this will now be what? 21.2. I take it back to 21.2 and 18.2. So my average titer will be what? 18.2. If I like, I show you about it. That's my first titer plus my second titer plus my third titer, all over what? 3. So this gives me 18.20 plus 18.10 plus 18.20 all over 3. So what will this give me? Whatsoever I get here, this should give me 18 point something. That will be 18 point, let's say 1, 1, 5. Whatever value I get here, it must be recorded in 2 decimal places. It must be recorded in 2 decimal places. So let's calculate it. So that will be 18.1 about 18.186 or something, right? 16 something, okay? About 18.16 cm what? Cube. So this is my average what? Titer value, which I will now use for my calculation. So that is that on your what? Concordant values. Then the third error that you must be wary of is what? There must be no alterations. Yes, there must be no alterations of values on your table. Yes, in as much as you want to be smart, right? You must be intelligently what? Smart. Now, yes, you want to get 18 points. Okay, like this now, we had 21.5 here, and we got 21 points. So 18.50, and you have seen that this is out of this range. So you want to force this to fall within this range. So you now do this. You now use your pen to do this. That is wrong. You will be penalized for alteration, because the examiner will know that you are trying to what? To cheat or to force your titer values to rhyme with probably your supervisors or your teachers or titer value. That you have an idea of what your teacher's titer value should be. Right? So you have to be very, very careful. So in that case, you don't do this. You don't do this. Carry out your titration first. Your rough records with pencil. Rough records somewhere. When you are sure of your values first, before you transfer them to your booklet, with pen, with ink, right? And neatly transfer it to your booklet, that's a booklet with what? Ink. You don't alter what values. And when you are done, completely erase the pencil traces. There should be no pencil tracing found on your what? Answer booklet, except when you're drawing a diagram. Take note of that. There should be no pencil tracing found on your answer booklet, except when you're drawing what? A diagram. Okay? Then that is so, otherwise you'll be penalized for what? Writing in pencil. That's -2. -2, yes. And then, the worst of all, those of you that are not always careful, that don't pay attention to details, that don't listen to what your teachers tell you, be careful of this. When you do this, if you hastily go and start what you cannot finish, maybe you get stuck on the way, and then cancel your table. Cancellation of table. Once you cancel your table and start a new table, you lose what? 4 marks. -4. That's cancellation of what? Table. So nothing Nothing, I repeat, nothing should make you cancel your table. No matter how desperate you may be. You alter the values and lose some marks than cancelling your table and losing 4 marks. Are we together? And ensure you work with your teacher's instructions. Is that understood? Don't bother yourself about what any other person is doing. Stick to your teacher's instruction before the examination day. Stick to your teacher's instructions before your examination day, because your script will be marked against your teacher's report. Is that understood? Fine. Then when writing equations, if there's a question that involves you writing equations, always add your word state symbol. It may not be compulsory, right? If you are not sure of the state symbols, you can be silent on it, remain silent on it. Right? But if you are sure of the state symbols, fine. It's better you don't write a state symbol than writing the wrong state symbol. Are we together? Fine. So those are the common errors that students commonly make in their table of values in volumetric analysis, and this makes them lose some avoidable marks. Are you together? Then most of all, the most painful part is, if you don't work with your teacher's instruction, you stand a chance of losing 8 marks. You stand a chance of losing 8 marks. When once okay, so if you want to know that more in details, chat me up. Drop a comment, and I'll tell you why you might end up losing 8 marks. Are we together? All right, so now, having done that, let's now solve. Let's get to the calculation. Yes. I just hope this is recording well. Okay, so now look at this question. Funny enough, I cannot see I don't know what I did. I can't see your comments. Sorry about that. This question says A is a solution of 1.58 grams of KMnO4 in 1 dm cube. B is a solution of hydrated iron 2 tetrasulfate 6 containing 2.52 grams of FeSO4.xH2O in 250 cm cube of solution. Put A into the burette and after all the other stories, how to carry out titration, how you add 25 cm cube of B and add 20 cm cube of concentrate H2SO4, blah blah blah. Fine. Then the equation of the reaction is this. From your results and information provided, calculate 1, the concentration of A in moles per dm cube. 2, concentration of B in moles per dm cube. C, molar mass of FeSO4.xH2O. Then D, number of molecules of water crystallization in X. Number of crystallization X in FeSO4.xH2O, and that's hydrated salt. Then number of moles of iron in the volume of B pipetted. Fine. So what are we doing? What are we doing here? Okay? We are told to find the concentration of A in moles per dm cube. So what are we given? We are given the concentration of A in grams per dm cube. In your volumetric analysis calculation, you are likely to make use of 2 out of these 3 formula I'm going to write on the board. Concentration in grams per dm cube, that's your mass concentration, equals to what? Concentration in moles per dm cube times molar mass. That's 1. 2. Your CAVA over CBVB equals to NA over what? NB. 3. N, which is still from which this formula was derived. Number of moles equals to what? Concentration times what? Volume. That's concentration in moles per dm cube. Number of moles N equals to concentration in moles per dm cube times volume in dm cube. Mass per dm cube equals to what? Mass times 1000 over volume in cm cube. So these are the likely question. These are the likely formula you will make use of in your volumetric analysis. You may make use of one, at least you make use of 2 of them. At least you make use of 2 of them. Then, given this type of question or the salt involved, which is a hydrated salt, right? Your instruction, take note, the instruction given was anhydrous salt. Yes, it was anhydrous. But since iron 2 sulfate also exists in the hydrated form, they can bring this in your question and ask you to calculate the water of what? Crystallization, even though you're working with the anhydrous salt. Are we together? So it means that expect question on water of crystallization. Fine. So let's start first. When we get to the water crystallization part, we will now look at or see how to apply the formula for solving water crystallization. All right? So let's start with concentration of A in moles per dm cube. Concentration of A in moles per dm cube. What are we given? We are given 1.58 grams of KMNO4 in 1 dm cube. What is that? In other words, we are being told that, okay, we are given what? Concentration of KMNO4 in grams per dm cube. That's what they are telling you. What is 1 dm cube? 1 dm cube is what? 1000 cm cube. Is it not? It's 1000 cm cube. So by the time you substitute 1000 here, 1000 cancel 1000, the mass is what? 1.58. That is 1.58 grams times 1000 all over what? 1000. Right? All in what? dm what? Cube. So this will give you what? 1.58 grams per what? dm cube. Or for what? Concentration in grams per dm cube of what? A. Are we together? They've already given you that in the question. It's there. dm cube. You will have to make use of this. Why? Because this is the formula that relates concentration in moles per dm cube with concentration in grams per dm cube and molar mass. Can you get molar mass of A? Yes. You know the elements that make up A. And you know you are given the names of atomic numbers. So you can easily calculate the molar mass of what? A. So it means that this is the best formula you can use to find the concentration of A in moles per dm cube. You cannot use this. Why? Why can you not use this? Because you have the volume of A, which is your titer value. You have the volume of B, which is what do you call it? which is your volume pipetted, but you don't know the concentration of B. You know the concentration of B. And you say yes, but you can use it because what do you call it, the mass concentration, the mass dissolved in the volume to get the concentration in moles per dm cube. You cannot, because you don't know what X is. So since you don't know what X is, there's no way you can use this value. You cannot find CB. You don't know what CB is. Are you together? Fine. And the only formula you can use is this. The only formula you can use is this. So let's clean up this. So A, having calculated the concentration or given the concentration of A in grams per dm cube, concentration of A in moles per dm cube will be given as what? Concentration of A in grams per dm cube divided by molar mass of A. You don't, so how do you calculate molar mass of A? But molar mass of A equals to what? AR of potassium plus AR, relative atomic mass of manganese, plus 4 times AR of oxygen. So that's what? 39. 1 times 39 plus 1 times 55 plus 4 times what? 16. You must show how you got your what? Molar mass. You don't jump any step. So this gives us what? 39 plus 55 plus 64. And if you calculate this, this should give you about 158 grams per mole. You add your units. I'm going somewhere. Okay? So after this, you now do what? So you substitute into this equation. Therefore, concentration of A in moles per dm cube will be equal to what? What's 1.58? 1.58 grams per dm cube divided by 158 grams per mole. And if you calculate this, this will give you 0.01. You don't stop there. Right? You add your what? 2 zeros at the end. Mole per what? dm cube. Why is that so? Your record, your answers to your concentration values, calculated concentration values, must always be in what? 3 significant word figures. Are we together? Your answers must always be in 3 significant figures with the correct unit if you must get this mark. Are we together? 3 significant figures. Yes. All right. So having that, so that gives us what? The concentration of A in moles per dm cube. Next, we are going to find concentration of B in moles per dm cube. So what do you think will be the correct formula to use in finding concentration of B in moles per dm cube? Definitely, we cannot use concentration in grams per dm cube equals concentration in moles per dm cube times molar mass. We cannot use it because we don't know what the molar mass of the hydrated salt is, since X is what? Missing. Are we together? So the only formula that we can use will be what? As CABA over CBV because of what? NA over what? NB. Is that understood? Now, as a clue to let you know that you are on the right track or you're doing the correct thing, your values for the values for your concentrations will always be, concentrations in moles per dm cube will always be less than 1. Yes, most times, 98 to 99% of the times, your concentration will always be less than 1. So it will always be 0 point something. Concentration in moles per dm cube will always be 0 point something, not above 1, because most times you are dealing with dilute solutions. Are we together? Are we together? But it is only your concentration in grams per dm, that's your mass concentration, that will likely be greater than what? 1. Are we together? That's in grams per dm cube, right? Okay. So, having calculated this, let's move on to B. Drop your comments, even though I cannot see your comments now, because of the wrong setting, which I don't know. I will always attend to it after the end of the live stream, right? Okay, B, concentration of B in moles per dm cube. So you are going to use, concentration of B in moles per dm cube. Please note that these are not WAEC questions in any way. We are only using this as an illustration to show you how to solve questions, related questions in what volumetric analysis. So don't go and cram this. Don't cram this. If you cram this, if you cram all what you have been doing, it's at your own peril. Still carry out your independent study and research. Are you together? Ask it to just guide you. There's something you don't understand, you ask. Don't cram anything. You will not take any responsibility when anything goes wrong. Alright? So B is a solution of hydrated iron 2 tetraoxide 6 containing 2.52 grams of blah blah blah. Now look at this. Concentration of B in moles per dm cube. So now B, we are going to use what? Using what? CAVA over CBVB equals to what? NA over what? NB. Now, what's the mole ratio of NA over NB? NA to NB. NA. A is potassium per manganate 7, while B is iron 2 tetrasulfate what? 6. So, from this ratio, iron 2 is 5. From the equation of reaction, you can see that iron 2 is 5, while the manganese or manganate iron is what? 1. So we apply that here. So this will give us what? That will be what? 1 over 5. Or you can write this out again. It's very, very important. CAVA over CBVB equals to what? 1 over 5. Because they are going to award you mark here. Yes, you are awarded mark for this correct mole ratio. Are we together? Fine. Then, what are you looking for? You're looking for what? CB. You make CB subject of what? Formula. You make CB subject of formula. So your CB will be equal to what? CA VA times what? 5 all over what? VB times 1. Before you substitute the value, don't go and substitute your values here. If you substitute your values here, you lose this mark. Are we together? Okay. So here now, so CA, what's our CA? CA is 0.01, yes. Then VA, our titer value, that's 18.6. 18.16, that's what we got. That was our titer value. Then times what? 5. Whatever you get as your titer value is what you will use here. Forget about what I'm doing here. This is just an assumption. So whatever you use as your titer value is what you're going to use here. I repeat, the mark guide does not have any standard titer value. No. Each titer value is unique to each school. Are we together? What they want to see is the consistency in your readings, your concordant values. Are we together? Fine. So all over what your VB is the volume of the base pipetted. That will be what? 25. Then times what? 1. So if you calculate that, what will you get? Try to call. I can't see your chart. I know you'll be calculating that too. So that's 0.01, okay, times times 5. That's 0.098 divided by divided by 25. And that gives me what? 0.03632. Right? But my answer must be in 3 significant word figures. So that's approximately what? 0.0363 moles per what? dm3 in 3 what? Significant figures. Can you see this? Yes. In 3 significant figures. Are we together? Are we together? Okay. Yeah. Can you get that? Fine. Okay, so that is your value. 0.0, not 0.03, not 0. Don't go approximately to 0.04. If you do that, you lose the 2 marks here. So what happens here? You earn 1 mark here, you earn 1 mark here, you earn 1 mark here, and you earn 1 mark here. That's 4 marks. If you don't approximate correctly, or you don't use the appropriate number of significant figures, you will lose this mark. And if you don't also use the correct units, you might also lose this mark. Are we together? Then the next thing that we'll do is 0.0363 mole per dm3. That's the molar concentration of. Can I clean this? Yes, I should. All right. So then the molar mass of what? Fe. Can you see? Because since you don't know the value of x, there was no way you could have calculated the molar mass here, like I told you earlier. So now you need to calculate the molar mass of what? X. And you just calculated the what? The concentration of B in moles per what? dm3. So from that formula of concentration in grams per dm3 equals concentration in moles per dm3 times molar mass, we are going to make molar mass subject of formula. So molar mass, you see now, molar mass of FeSO4 dot XH2O will be equal to what? Concentration in grams per dm3 of B all over what? Concentration in moles per dm3 of B. Right? So now, but look at what they did here. You are not given the concentration of B in moles, the concentration of B in grams per dm3. You are given as a fraction of 1 dm3, 2.52 grams of B in what? In 250 cm what? solution. But concentration of B in grams per dm cube of B, you have to first of all convert this to grams per dm cube of B will be equal to what? Equal to what? Mass of B over volume in cm cube. Then that gives us what? 200. What do we have here? What's the mass? 2 point. All over. What's the volume? 250 cm cube. 250 cm cube. That's what? 1,000. Why the 1,000? Remember, 1,000 cm cube make 1 dm cube, right? So this is cm cube, and this should be what? Dm cube. So this will cancel out this. So you are left with what? That's 2.52. This should give us about what? 10.06 grams per what? Dm cube. Are we together? Can you see this? Yes. Yeah? 10.06 grams per dm cube. So you're not going to substitute this value into this equation. Therefore, molar mass of B will be equal to what? 10.06 grams per dm cube divided by 0.03 cm cube. So what would that give us? 10.06 divided by 0.0363. That gives us 277. That gives us 200 and what? 77.13 mole per dm what? Cube. Let's calculate this and confirm that that is correct. 2.52 times 1,000 equals this divided by 250. That's 10 point. That should be 10.08. Okay, that should be 10.08. So 10.08. What we get here? Divided by 0.0363. Yeah, doesn't matter. So still around that. So the 2000.6, let's say 69 per mole, not mole per dm cube, please. Grams per what? Mole, because that's the unit of what? Molar mass. So from here now, you get this? Yes. So from here you are going. Now move on to the next question, which is what? The number of molecules of water of crystallization of X. Sorry, of water crystallization X in FeSO4. Okay, so let's clean off this. Okay, so that gives us what? So molar mass number of molecules, or let's just say value of X value of X calculated as what? Molar mass of FeSO4 dot XH2O will be equal to what? AR of Fe plus AR of sulfur plus AR plus 4 times AR of oxygen, then plus X times MR of water, right? What's the R of iron? Okay, what's the molecular mass? Molar mass that we calculated, that's 277.68 equals to this iron. What's the iron? 56 plus 32 plus 4 times this, 4 times 16, then plus water is 18, right? Molecular mass of water is 18, that's plus 18 what? X. So this 277.68 equals to what? That would be 56 plus 32, that's about 88 plus 64 plus 18x. So from here, you can say 18x equals to 277.68 minus, if you add up this, what do we get? That's 2, and that's 2 carry 1, 14 plus 1, 152. 152. Can you see this? Yeah. So, what does that give us? 277.68. 277.68 minus 152. What does that give us? 125.68. So what will X be? My X will be what? 125.68 all over what? 18. .68 divided by 18. That's what? 6.98. That gives 6.98 based on the theta value that I use. So your value of X will depend on the theta value that you used. Are you together? So and your X being water crystallization, molecules of water crystallization must always be so. Here, approximately what? 7. Are we together? So X here is approximately 7. So that is that for the number of molecules of water crystallization. Which is the last one, is how to calculate the number of molecules of water, number of moles of iron in the volume of B pipetted. But before we do that, I also like to give the formula on how to calculate the percentage of water of crystallization in case you are asked to calculate the percentage of water of crystallization. Can I clean up this? It should be done by now. Okay? So percentage of water of crystallization is given as what? Mass concentration. In this case, should be mass concentration of water crystallization over mass concentration of hydrated times 100 over 1. But you don't know the mass concentration of water crystallization. But you know the mass concentration. You can calculate the mass concentration of the anhydrous. Are we together? Because so mass concentration of hydrated minus mass conc of anhydrous. No, let me bring that back here. Okay, percentage of water of crystallization mass of hydrated minus mass of anhydrous all over mass of hydrated. Then times what? Can you see this? Times 100 over 1. How will you get, what you're given here is the mass of the hydrated. How will you get the mass of the anhydrous? From the molecular mass, from the concentration in moles per dm that you calculated. You can use that to get the mass of the anhydrous, because you know the formula of the anhydrous. Are you together? So let's quickly do it. Mass of anhydrous, mass concentration of anhydrous FeSO4 is equal to what? Concentration in moles per dm cube of anhydrous. Yes, you can calculate the molar mass of anhydrous because you know all the elements present here. So that would be what? 0.0363 times 152, right? Times 152. And that would be what? 0.0363 times 152. This gives us what? 5.5. That gives you 5.5. Let's say 518 grams. Right? 5.518 grams per what? dm cube. Are we together? So it means that out of the 10.6 grams of this that dissolved in the water, 5.52 grams, 36 grams figures, 5.52 grams of this guy was what? The anhydrous. So you can then substitute that here. Are we together? Can you see here? Yes. So if you do that here, this will give us what? That is 10.08 minus 5.52 all over 10.08 times 100 over 1. What would that give you? Ten 0.08 minus 5.52 divided by what? That's 4.56 divided by 10.08, then times 100. Divided by 10.08. That will give you what? 45. Are you seeing this? Yeah. I'll give you 45.23%. 45.23%. That will be a percentage of water of crystallization. So this is how to calculate percentage of water of crystallization in case you are asked. It's different from calculating the number of molecules of water of crystallization. Are we together? I'm just trying to touch all the practicable areas that questions can come from in this titration. All right? Oh, sorry, in this volumetric analysis. Can I erase the board then so that I can answer the last question? I will be done for tonight. Please pardon me. Bear with me. Pressed and I don't know what I pressed and my settings. I don't know what's going on. Okay. All right. So the last one. Okay. So number of moles of water, of iron 2 in the volume of B pipetted. E. Number of moles of iron 2 in the volume of B pipetted. That will be, that's N equals to what? Concentration of B, concentration in moles per dm cube of B times volume in dm cube, cm cube. What was the concentration of B? 0.063, because that is what contains the iron 2. 0.063 moles per dm cube times 0.025 dm cube, and this will give you what? Zero point 0363 times 0.025. So this gives us what? 0.0009075 mole of what? Iron 2. If you like, you can express this in standard form, raised to power minus what? 4 mole of what? Iron 2. So that is that. So that's that live session on the 2024 on some common errors that can be made in the volumetric analysis, or students normally making volumetric analysis, and some calculations that we've just done in volumetric analysis. At least it will aid you in answering the question in this year's chemistry practical. So if you're able to obtain any value, right, kindly hit the like button and subscribe to this channel if this is your first time here. We would like to apologize to those of you who could not really get the correct view of this session. I don't know what happened to our setting. It just changed midway, so we'll try to work on it. But whatever be the case, if there's anything you do not understand, drop it in the comment section of this video. I'm going to upload this video. It will be uploaded. So just drop the comments there and we'll attend to it. We wish you all the best in your exams on Thursday. Be calm, very calm. Pay attention to details. Listen to your teachers. And of course, success will have no other choice than to be your friend. So until I come your way next time, I remain the Science Chef. Good night and God bless.